Okay, so we've implemented an array stack, but I also want to implement a list stack. And fortunately, this should be pretty quick to do. I hope I'm not proven wrong, but let's try this. I'm going to create a new class. It's going to be called ListStack. This is a stack based on a list. I want inherited methods, and I want to implement that superclass abstract stack. There it is. It's in BoundedStack source, which is what I want. And I'm going to add that E there. Keep it generic. Constructors from superclass. No, I just want the inherited abstract methods. Okay, so we've got a few methods to implement, but hopefully most of them will be easy. I'm not going to write Java docs for this one, but just know, actually, let me do the private variable. Since I'll be implementing this with a list, I'm just going to call it list here, and I haven't imported that, so I'm going to go ahead and import that. And I don't want the one from Java AWT, that's a GUI thing. Okay, and I also want a capacity. Okay, because normally a list does not have a capacity. A list is unbounded. And I'm going to make this capacity final. Okay, and then I need to set up my constructor. And as per the Java docs for stack, my constructor needs to be public list stack. It needs to take one argument, int max, and it's going to throw an illegal argument exception. Again, as per the, and this should be throws in the signature. So I'm going to say if max is less than or equal to 0, again, this is as per the instructor, throw new illegal argument exception. Wonderful. And what's this error giving? What's this? The blank final field capacity may not have been initialized. Give me a chance. Give me a chance. So first I want to initialize list. List is just going to equal, let's see, do I want to make this an array list or a linked list? I'm adding to the end and I'm popping from the end. I think I'm going to make this a linked list. I'm not really sure what the best implementation would be. New linked list. Okay, and then I'm going to have to import that. And now I've got to set the capacity, and hopefully it will stop complaining after that. Capacity equals max. All right, and what's the matter with linked list? Multiple markers, type safety. Oh, it wants me, that has to be generic, so I have to include the diamond notation there. And then I assume that these warnings are the variable is not used, and I guarantee you they will get plenty of use. Okay, so for capacity, I'm just going to return capacity. For clear, actually list, I believe, has a clear method. So I'll just clear that. For depth, that's just going to be the size of the list. By the way, let me just, maybe I'm assuming that this is obvious, but For my list, okay, if my list is A, B, C, okay, and my capacity is, say 20, okay, that means my stack, or I should say this, is going to be A, B, C, colon 20. Okay, so this is my abstraction, and this is my representation. All right, so it's pretty simple. I'm just going to add things to the list, and that will be just like pushing things onto the stack. Okay. So here we've got capacity, we've got clear, we want to implement depth. Okay, I'm just going to do return list.size. We want to implement is valid. Okay, that's the representation invariant. Is valid. What does it take for this list to be valid? Well, the only thing I can think of, so that's basically the constraints on these private fields here. The only thing I can think of off the top of my head is that capacity is going to have to be greater than 0. And it's going to have to be greater than or equal to the current size of the list. Okay. Off the top of my head, those are the only conditions I can think of. So is valid, I'm going to return capacity is greater than 0, so I'm just going to put it like this, capacity, and capacity also has to be greater than the size of the list. List size is less than or equal to capacity. Okay, and if those two things are true, our representation is valid. New instance, we're just going to return a new list stack. And we return a new list stack with parameter max, which is capacity. And I get the same error. Expression of type needs unchecked conversion. Let me see if this gets rid of that error. Yes, that actually gets rid of that error. So lo and behold, I believe with ArrayStack, I had that same error. And I couldn't figure out what it was. So I didn't do the diamond notation. Okay, well, that's fantastic. Glad we figured that out. All right, so pop method throws an illegal state exception. And let's see, remember we're not touching capacity. That's always going to stay the same. So there is a list remove method, which actually removes and returns an element. I don't want to get, because get doesn't return that element. And this is going to be the last element. So this is going to be list.size minus 1 is going to be the index there. Okay, so that's actually, I take that back. I want to throw an exception here. So if I'm removing from an empty list, I'm going to say if a list is empty, then throw new illegal state exception. Okay. I could be clever about it, and there's going to be an exception thrown by remove. Let's see, remove. Let me see if I can find the exception here. It throws an index out of bounds exception if the index is out of range. Yeah, well, if it's the last element, it's not going to be out of range as long as there is a last element. So really, I just need to check that the list is empty. I could be clever about it and do wrap this in a try-catch block and catch the index out of bounds exception, and then throw an illegal state exceptions if I catch the index out of bounds exception. But why torture yourself? Okay, this is a lot easier to do it this way. All right, so here I want to deal with these exceptions also. If element equals null, throw new null pointer, whoops, got to be a capital P, exception. If when's the illegal state? So if list.size equals capacity, okay, throw new illegal state exception. All right, and finally, we just want to push this element onto the stack, which means adding this element to the end of the list, and that happens to be exactly what add does. Add always adds it to the end of a data structure. And then finally, we have the iterator method. And the iterator method is going to be this: return list dot iterator. Look at that. We don't have to write a whole new iterator for the list. Isn't that fantastic? Okay, so it took us about 5 minutes or something like that to write this list class. It took us a long time to write the array stack implementation, but the list implementation was pretty quick. And it would be nice to test these, but that's probably something for another video.